Okay, we're going to be turning up a network of R7s, and we're going to turn them up using almost completely just the NMS. However, for this to take place, the nodes must be first prepped or prepared so that they can be visible remotely so that the NMS can access them. What this means is the NMS is going to use the IP connectivity in order to get visibility to the nodes. For that to take place, we must initiate DCN within the nodes first. And so DCN type 1, which I'm going to refer to as type 1, is simply DCN via an OSC connection. This diagram shows the basic infrastructure of such a DCN connection. For the process to begin, the basic infrastructure must include first internode fibering. We must be fibered from site A to site B to site C, and if this is a ring configuration, then back to site A. So we must have our backbone fiber in place. Secondly, we must have any client connected fiber that would hand downward to the OSCM card itself. That OSCM card, being a layer 2 switch, is going to provide our interconnectivity between our Ethernet layer and then of course our layers 1 and 2 access to the box. And so once those are in place, we can begin working with each node. Each node will need to be prepared in terms of IP address, node name, system IP or system ID, which is host name, and of course the basic connection between the optical Ethernet portion and the electrical Ethernet portion of the box. These will be connections that we refer to as either LANs or links. And so what we're about to do is establish that within each of the boxes. First machine that I'm going to access is going to be the first piece of hardware. I've run a physical connection from my laptop straight to the NCU card of one of the shelves. This shelf that I've physically connected to is going to be our Site 2 location, or this guy right here. I've made this connection off the C1 port of this shelf, however, the C1 port of the NCU. And so I'm going to need to set my laptop to be in tune with that very connection. I set my IP address to a matching domain of that interface. The interface's default IP address is going to be 192.168.1.1, and so I'm going to need my laptop somewhere within that range. So 192.168.1, and I'm going to give myself 100. I'll set my subnet mask as expected by Windows. Don't need to set any of the remaining information here. Once I've done that, I simply access Telnet to get to the box. The default login is admin and then chgme.1a. Here's our node. So to prep the box, I need to first give it a name. I'm going to call this node Enterprise. I'm going to give it the system ID or host name of the same name. Enterprise. I set the IP address, and I'm going to give this one an IP address reachable from our network. I'm going to call this one 10.19.41.20. Set my default gateway. Apply it in. And so now I've created the shelf's identity. I've created its both telecom and datacom identities, IP addresses, etc. Now I have to make that subtle connection, that link between what is electrical Ethernet and that which is optical Ethernet. So in this case, I'm going to build this connection across the backplane of the shelf. And the connection is initiated only within the NCU. The NCU, serving as a router, allows us these types of connections. I go to Service Management, into the shelf, and into the NCU. I make the entity necessary available. LAN 1A1. I want it to propagate the shelf's IP address, so then I set it as unnumbered. Now that I've done that, I need to tie it down to what the greater universe is going to have. Here that means the OSCM card needs to tie to that NCU card. And so to make that connection, I need to go to the OSCM card. I go into its module, and I go to config. We set that LAN AID, which is that uplink for that card. We set it to the same entity that we just created, LAN 1A1. It's applied, and that's all there is to it. From here, I need to reboot my hardware in order for everything to be aligned. Once that happens, I'll be ready to move on to the next node. We start the reboot process. Once the reboot has completed, we'll move to the next node and then the final node. So simply remember to repeat this process for every machine involved on that network. Once it's done, we'll discuss more turning up this box via the NMS. Now that we have finished prepping each of the nodes in their DCN to be connected into our bigger network, that means that our NMS should now be able to find those nodes should we try to add it into our NMS network. So now what I need to do is create a subnetwork for those NEs and make our build happen. So I'm going to right click on the network, on the root network. I'm going to select new subnetwork. I'm going to give this one a name. I'm going to call this one my demo subnetwork. I select my discovery, then the IP range of my new nodes, 10.19.41.1 through, I think the last one that I'm going to put up there is 30, so 30. Scan for them, there they are. I don't have to let that cycle complete. I can just hit stop because I know there's no other nodes in that network. I hit OK. Back at this larger screen, I hit OK again. It pulls in the rest of the MIB information for those nodes. Now that the subnetwork screen is finished, let's get a look at our final network here. There are our nodes in our system. Now we're ready to start the turn-up process. We can access the node in any one of our basic methods. We can access it via its CLI, via the element manager, or via the web GUI. What I'll do is I'll start my process via element manager. I need to review once more my topology to be certain how we're going to establish these nodes. I refer back to my map. These are our nodes, Site 1, Site 2, Site 3. The respective order that we've placed them into our system is as follows. Galactica, Site 1. Just to review it, network element properties, there's that IP address. Site 2, Enterprise. So network element properties, 20. Site 3, Pillar of Autumn. Network element properties, 30. So the proper arrangement of our devices appears to be in this order, clockwise. Notice that there are no lines drawn for them for their topology. I can manually add those lines, but I decided I'm going to let the system do it for me once I've established the rest of my node. So let's start the turn-up process. We go into Galactica. I'm doing it via via Element Manager. Element Manager opens up. Here's our node, but we're waiting for it to finish loading whatever current alarms it thinks it sees or anything of the sort. Notice that in our shelf view, we have exactly one card highlighted, or two cards highlighted in blue. These mean that these cards are in a nice and happy state and that there are no alarms present. However, notice that of all the other cards shown in the picture here, there's nothing else highlighted indicating whether there's a problem or not. That is because these cards have not yet been provisioned into the system. However, they are seen by the hardware's inventory, hence their pictured representations here. We extend our list. Notice that everything is in a UAS state. The auto-config devices on the FSP3000R7 are the NCU, the SCU, the OSCM card, and the power slots. And so right now, the only ones that can give us an alarm are the NCU and the OSCM, hence the two blues. Let's go ahead and bring these cards into existence. I'm going to start with my OSFM cards. So I right-click on the card's representation. I create the module. The OSFM card is simply reading the part numbers of that OSFM card, so it sees that it's an S1510. It's saying automatic in service, but being a passive device, it doesn't really matter if it's in service or not. Simply hit next, 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 and finish. These shelves are going to be arranged in a ring, so I want to follow up by getting my other OSFM card into the picture here. I want to bring my EDFAs into the scene. I'm going to start with my preamps. But please note, if you're dealing with a dual stage EDFA like this DGCV here, note that you have two stages you have to build. So once it's in this status, you're still not quite done yet. So right click again, go to create, and then you have to create each of your two stages within that EDFA. The primary stage and the mid stage. So within that amp, I had to create my two amps. Then I go to my post amp. Well, I want both of my preamps first, just to get them out of the way. Looks like I got an error here. We'll retry it. Worked this time. There are our two stages, and then to our single stage post amps. So we've got our EDFAs out of the way now. Let's go to our active cards. going to start off with my 2WCC card here. Reviewing how it's arranged in my map. The 2WCC card is to be established as a hot standby. That means I'm going to need a single client interface while having two network interfaces. So let's get back to that card. Hot standby. So under that card, two networks, one client. Whenever you establish these type of situations, you want to start with your network ports first. So I'm going to set my network port. Both network east and network west. Well, starting with network east, I need to create its facility, select its channel, and give it a bandwidth. And so the channel that this one should be serving is going to be D04 on the 4CSM. Well, the channel for D04 on a larger scale, that would be D04 or channel 3. So D02 is channel 1, D03 is channel 2, and D04 is channel 3. So I'm going to need to set that one for D04. Now the facility type here, it says OTU2 with 10 gigabit Ethernet payload. That means that I'm going to have Ethernet synchronous information placed within the ODU layer of my OTU2. I don't need that because what I'm going to be transporting is an OC192. So that to be the case, I need a generic overhead or just simply ODU2 information there. So to do that, I need to pair this as simply an OTU2. Follow through with next, and eventually apply. But one thing I want to make certain is that I've turned off my ALS functionality if I can gain access to it within this card. Certain cards won't always give you that option. And this one is one such card. And I need to do the same thing for the west-facing interface as well. Except the west interface is going to be D11, which is channel 12 on a 40 CSM. The reason why I'm getting these options on the facility is because these happen to be pluggable tunables. And so what I'm doing is I'm tuning the tunable pluggable. Picking D11 as my channel. almost done with this card. We'll know it's complete when the plus sign appears beside the card. And there it is. And if you look at the shelf here, we now see an alarm status for each of the cards that we've pulled in. Now I want to move to my WCC cards, which are here and here, and their corresponding channels. So 1-8 is going to be D02. And with ALS turned off. I need to set my client as well. These cards are going to be using a protection status, and so as being such, I have to treat it appropriately. Now what it's telling me, once I right clicked, it read the part number of what's in that client facing port. It's telling me it's an XFP of a given number, but it's a gray channel card or device. So I hit next, and now I see that channel that was referencing 1310 or gray 1310. Next, automatic in service is its default state, telling me that the data rate of that pluggable is a 10 gig, which tells me it's an XFP that's in there. I hit next, next, and finish. So now the client has been taken care of. Now the additional creation that I can do here at the network interface is to set up fiber-to-fiber protection for the network, or to set up GCCs, or generalized communications channels. Right now I'm not going to set up any of those. Now I have to proceed to set up the matching card, and that's at slot 9, which is also running D02. What I'm now doing is creating the client payload. In this case, it's going to be an OC192. So now I've provisioned in all of my two WCC cards and my two WCC cards. I've brought into existence all of my EDFAs, both my OSFMs, and what's remaining are my protection module, my 4 TCC module, and my 5 TCE module. I'm going to set my 5 TCE as a transponder. This way I can say I can isolate the bandwidth coming out of the top and the bottom of the card and treat it as though it were another WCC card. The 5 TCE card's matching channel would be D03. I set this one for an OTU2 propagating 10 gig fiber channel payload. I haven't plugged the client into this one yet, but because it's in transponder mode, the card is expecting its full bandwidth out of its client interface. So here I will select 10 gig. Mine says choose solely because I don't have a part in there yet. So there's no part number to be read. But what I'm in fact doing is ghosting in where I am going to plug in a SFP plus. And so the card will go into AINS state until I add an actual device there. The 4 TCC card, that one's going to be running DC1, which is channel 4. It's in multiplexer mode, but that is its hardware default. There really is no other option to build from that. Create a network interface for this card, turning off automatic laser shutdown, and I'm building it for channel DC4. DC1. Once again, the card is giving me an offer of what I would like to connect up. I'm not going to give any client ports for this card just yet. I'm going to leave that one up to mystery for the moment. Bring in the 4 CSM. And it appears that all of our cards on our shelf have now been configured. I can quickly get around to doing that to the next several nodes, the next 2 nodes. So what I'll do is I'll move to site 2. Just like site 1, I want to constantly review my topology. I bring in all the necessary cards immediately. And I'll continue the process, but this time I'll do it silently. Okay, continuing to build. Now I'm coming across my first ROADM. If I remember my network diagram, I can get that detail together. ROADM 1 at 1.5, ROADM 2 at 1.11, and ROADM 3 at 2.7. Deployment modes were in fixed, and C select. In that order. In fixed, ROADM number 1. C and C interleave band simply means access to all 80 channels in the C band. So ROADM 1 is almost out of the way, but now I need the corresponding optical modules that correspond with its connections to the network and to other nodes, other ROADMs. So starting with my network interface, then my connection to ROADM number 2, then my connection to the third ROADM. Reviewing my diagram, I'm not doing any client drops for that ROADM, so that's also perfectly okay. ROADM number 2, ROADM number 2's connection back to ROADM number 1, ROADM number 2's connection back to ROADM number 3, and if we look carefully, we'll notice that ROADM number 2 does actually have a client-side drop, so then we have to acknowledge that as well. The last ROADM to play with is ROADM number 3. ROADM number 3 is in a slightly different deployment mode. It's as a C-select ROADM. We give it its connections back to ROADM number to a network, which in this case is downward to its customers, hence the C-select mode. This ROADM's connections back to ROADM number 1, looks like we ran into another error. Let's try that again. And its connection back to ROADM number 2. I'm going to continue to silently bring in my other cards here. It's taking a little bit of time, but it's going to finish. Since I have ROADMs in my node, I'm going to need to build cross connects for these ROADMs. So I'm going to go ahead and start establishing that now. So following my signal flow, I've got D02, D03, and D04, or effectively C1, C2, and C3, flowing across. Now C1, or channel 1, is going to terminate at the far end. Channel 3 is going to terminate at the far end as well. Channel 2 terminates at the next node. This means that I need all three of them on the network interface for my ROADM at degree 1. So C1, C2, and C3 are going to be N1, N2, and N3 of ROADM 1. So then I go to my ROADM for its network interface, and I build these connections, or these availabilities. So there's N1. I'm doing this from the wrong ROADM. So we'll start it at the proper ROADM here. Now doing that at ROADM 2 is not any harm because it does land over here. One for channel 1, one for channel 2, and one for channel 3. And because channel 3 is terminating within that first ROADM, or channel 2 is, then I'm going to need to set up a drop for that one. However, that one's going to be dropping at ROADM number 3. So I need to build that drop to ROADM number 3. Now we can move to create our cross connects. Now we could do it from the ROADMs themselves, but since we're using Element Manager, we can build them all from a centralized location. We've created all the parts that we need to make these cross connects. We've built them we've set them in as optical channels for the network and client interfaces, and we've done them at our corresponding ROADMs that will be supporting all of these said connections. So from that centralized location, we go back to the node's name, right click, and we have an option here to view cross connects. Notice that the screen is empty. We simply select create, and we take stock of something known as path node. Now this is for equalization. We need to set an offset so that we're not equalizing one channel or a set of channels on two spans simultaneously. And so we need to take into account where the source of light is. Well, when you think of a path node, the best way to think of it is one basic principle. Light travels in one direction, away from its source. And so anywhere where our light is at its source, that is recognized in that direction away from that source as path node 1. For example, if I have a channel that goes from site 1 to site 2, like this 5 TCE's channel, well, from here, this is creating light to send in that direction. If this is the case, then this starting point would technically represent path node 1. There's no ROADM here, therefore no cross-connect to build, therefore the word path node is irrelevant to this node. However, with respect to this ROADM that's going to be delivering that service, I look in that direction. That cross-connect means that I am the second in that path. So if I'm created here, then this becomes path node 2 in the direction as it's landing. This also means that in the return direction, this one's creating light, and in doing such, this becomes the source. So in that return direction, this is path node 1, landing at path node 2. So to build it in our cross-connect scheme, we do the following. We start the process to build our cross-connect. We look at that channel that we're going to build. Let's see, this one was corresponding to D03, which is channel 2. So then I'll build for that channel 2. Channel 2 coming in from the next hop inward. So I'm selecting 15N2. And that one says logically it can only drop at client channel 2 on ROADM number 3. Facility type, well, that's a 10 gig connection. Generically, OTU2. Path node in that direction as it is coming in. This is path node 2. In that direction. The return path, it wants to know, what am I going the other way? Well, the other way I'm the source, so I must be path node 1. So going from network to client, as in landing from somewhere else, I'm the second hop. Going from here back outward, I'm an add connection, and the rule of thumb is that all add connections are path node 1. I hit next and finish. There's our cross connect. We'll build another cross connect. The next cross connect is going through as a pass through. D04 and D02 both land at our far end in our network. So that being the case, I'm going to be path node 2 in both directions. So D02 going to D02, facility type, OTU2, path node 2, other direction, same thing. And lastly, same thing here. So there are our 3 cross connects. However, we're not done yet because they now have to be enabled. There are all 3 of our cross connects, and all 3 of them are telling us that they're in service and running normally. Okay, all three nodes have now been turned up using solely the Element Manager software. The more advanced features that include control plane details, we can continue on several of them from Element Manager. However, some of the preparation work for them still needs to be done from the CLI or the web GUI. And so we're going to need to switch over to one of those two tools in order to create such things as our optical lines and some other control plane very specific details.